Hi, today we're going to be talking about the mean, median, and mode. Three core aspects of statistics that we use all the time in our lives. They're really universal, and many times we use or reference these things without even meaning to. We're so used to them, we use them without even thinking about their mathematical context. So, what are mean, medians, and modes, and why are they important? Well, they're important because they each tell us something very, very important about a large group of objects or things. A big collection of something, we can extract very, very useful information out of that collection using the mean, median, and mode. And these three things are really the core of statistics. So, what are they first and foremost? Well, to answer that question, I'm going to start off with a pretty common example, right? Say I'm at my birthday party. I'm so happy. And I'm going to draw a picture of me at my birthday party because I am so happy to be getting 1 year older, right? I have a big smile on my face. And it's my birthday party, so I invited a group of friends. And honestly, I'm pretty bored at this birthday party. I'm not having the best time. So I'm going to make a little game, right? And I say to myself, I wonder what the typical height of someone that comes to my birthday party is, right? What's the average height of somebody that would come to my birthday party? Say I want to get a metric of, I'm friends with, this average height person, right? How am I going to do that? If I measure the height of everyone in my birthday party, which is, number one, a weird thing to do, I don't get that answer. I get the height of every single person at my birthday party, but not what the height of the typical person would be. How do I answer that? How do I determine what the typical height of a person is? Well, we use something called the mean. And the mean is, unsurprisingly, since we use it all the time in math, a mathematical word, right? It comes from Latin, medius, which means in the middle. And that's because the mean is used to try to answer the question I just asked. What's the typical height of a person at my birthday party? To do that, we're going to try to find the height of somebody who would be in the middle of all the collections of heights, right? So let's say I'm having a small birthday party, and there's one guy who's 60 inches, and there's another person who's 68 inches, and there's another person who's 70 inches, and there's another person who's, let's say, 80 inches, right? I've gathered up, I've taken all their heights, and I have this collection of information. What am I going to do with it? Well, when we use the mean, we will add up all the values in a collection, right? And divide them by the number of values that we have. In this case, we have 4 values, so I'm going to divide some of this by 4. Right? So in general, right, the mean, if we have a collection of something, we add up each value in that collection and divide it by the number of things we have in a collection. And that gets us the mean, or more commonly, the average of that collection, right? For example, if I were to take all this and I were to add up all these heights, right, I would get 140 plus 138 over 4. I'm just doing the math now. And that's, in turn, 278 over 4, which is, a little division. I can just do some division. So a key thing is with this, usually you'll get to use a calculator, but that's not always a given. So in cases where you don't have a calculator, it's always important to kind of do the process by yourself. Because it can't be had. All right, I get 69.5. So the average height of somebody coming to my party would be 69.5 inches. All right, that's great. So I can just use the mean whenever I want to find the typical thing, the typical value of a collection of data or information, right? I can use it to find the typical height, or the typical weight, or the typical, arm length. Any sort of measurement, I can use the mean to find the typical or the average. That works for many data sets, but not always, right? Let's say I had, these 4 people, And then I had a giant. And no exaggeration, I had a literal giant. Somebody who was 1,000 inches tall. Now, of course, this is impossible when we're talking about heights, but it's pretty common in other contexts. Say I'm measuring how many stories a building has, right? I could look down my street and I could say, okay, well, there's one building that has 4 stories, and then there's another building that has 6 stories, and then there's another building that has 8 stories, and then there's a skyscraper which has 50 stories. If I were to find the mean of this data, I would add up 4 and 6 and 8 and 50 and divide that all by 4. And the result that I would get would be a number greater than 4, greater than 6, greater than 8, but less than 50. Right? If we actually do the math, we get 68 over 4, which, if we do the math, you get 17, right? Is the typical is the typical story length of a building 17 stories, right? Well, 3 out of my 4 buildings are not 17 stories tall. They're much less than that. And that's the problem with means. We can get very, very large, very, very small data points in our data set, which can really, really change what the mean is. We call these outliers. So in this case, 50 is my outlier. It's a number that's way, way bigger than all the other numbers, all the other points of data that I have in my collection. And as a result, my mean gets really, really changed up, right? And it can become unrealistic, right? 17 stories is not the average or the typical height of a building. It's just not. So in cases like that, we oftentimes use instead the median. And the median works to kind of counteract outliers and get more accurate measures of what the typical value of something is. So what is a median? Well, it's another Latin word. So it comes from medianus, meaning in the middle. So, like the mean, it's trying to find something that's in the middle of something. And it does this in a very, very different way, in a way that I think is easier. A little trick that I use for remembering the mean from the median is that the mean, it's pretty mean to calculate, right? You have to add up all your numbers and divide them by however many, occurrences you have. It's a lot of work, especially if you're doing it by hand. The median, however, is a lot easier. The median represents the true, if you want to think of it, typical, right? The 50% value, right? What's the number that's in between all of my data, right? So for example, let's say I'm still measuring stories, so I have a 4-story building, a 6-story building, an 8-story building, a 20-story building, and my 50-story building, right? If I were finding the median of this data, I would want to find the number that's in the middle of all this data, and I would do this by getting rid of my lowest data point, then my highest data point, then my next lowest data point, and my next highest data point, until I'm left with a single data point. In this case, 8. That means 8 stories is the median height of a building. And honestly, looking at my data set, that seems pretty realistic. A lot more realistic than if I added up 6 and 4 and 8 and 20 and 50 and then divided that by 5. I get a much bigger number, which would be much more unrealistic. This way, I'm still in a balance. So to use medians, it's super, super important that whenever you've given a data set, you make sure it's arranged from decreasing to increasing, right? If it's not that, you have to rearrange it that way. The reason why rearranging it is important is because that allows you to do this canceling out method, right? Where you look for the lowest and you eliminate it, and you look for the highest and then you eliminate it, and you continue down the process until you're left with one value. But sometimes you won't be left with one value. For example, say I didn't have that 50-story building. I had a 4-story building, a 6-story building, an 8-story building, and a 20-story building. So I get rid of my lowest and my highest data point, and now I have 2 data points left. If I get rid of them both, I won't have anything. So what do? Well, in this case, I want to find the median between those 2 points. Right? So I'm going to write this as 6, as 7, and as 8. Right? I can get rid of my lowest and my highest, and I'm left with 7. So in this case, the median story, the median height of a building in my neighborhood is 7 stories. Now, you'll notice whether I have to split apart data values and find the median within them, or just cross things out and be left with a single median. Depends on how much data I have, right? If I have an even number of data, I will have to do this splitting up method to find the median. If I have an odd number of data, right? If I had, instead of 4 data points, which is even, if I had 5 data points, well, then I could do this canceling out method and be left with a single value. So sometimes it's easier, sometimes it's harder, but in any case, it's easier and in many cases more accurate than using the mean. And now that leaves us with the mode. And the mode, he's a pretty popular guy. And like all the other words, he comes from Latin. But in this case, he means measure. Now, why does mode mean measure? Well, that's because we're not really worried about finding the middle value of something, right? No, we're trying to measure a specific quantity. In this case, the mode refers to the data value with the most number of occurrences, right? So let's go back to my height measure, right? Say I have a 60 inches, and then 64 inches, and then 64 inches again, then 68 inches, and then 70 inches, 70 inches, 70 inches, and then 90 inches, right? I want to find the data point that occurs the most. The reason why I said mode was a popular guy is because mode refers to the data point that is the most popular, that's featured the most, that's shown everywhere. So to do this, I just count up my data points. I see 60 occurs once, 64 occurs twice, 68 occurs once, 70 occurs 3 times, and 90 occurs once. And since 70 occurs 3 times, which is more than any other data point occurs, 70 occurs the most, and it is my mode. Now, an example for why we even need the mode and why we care about it is, let's say I have a huge collection of survey data. I went around and asked my entire neighborhood, my entire state or city, what's your favorite candy? And I had them all write it down on a piece of paper. And I have a lot of pieces of paper to read through, and I really don't care about what the average person thinks, what the typical person thinks. I really just want to know, what's the most popular candy? I'm going to use the mode for that, right? So if I have Skittles, M&Ms, and let's see, Reese's Cups. What's my mode here? Well, Skittles occurs twice, which is more than any of the other data points, so it's going to be my mode. Now, usually you don't use text or words when you're dealing with mean or median, but you can easily use them when dealing with the mode. The mode is the most versatile of the 3 basic measures because it's pretty easy to apply. And it's versatile in the sense that you can use it pretty easily in almost any collection of data, right? The mean or the median, it's a bit more work, but the mode is nice and easy. So those are the 3 core statistical measures: mean, median, and mode. Mean, it's the meanest one. It's hard. You have to do a lot of work, but it'll get you the typical, the average value, and you do that by adding up all the values in your data set and dividing it by the number of values that you have. The median, the one right in the middle, that 50% mark. For that, you're going to line up your values in increasing order, and you're just going to cross off the lowest and the highest and the lowest and the highest to the left with one single value. And that is your median. That's the value that's right in the middle of your data set. The mode, popular guy, most popular. What's the value in the data set that occurs the most. And that, my friends, is the mean, median, and mode. I hope I helped in some way, and I hope you have a great day.